Hello friends, welcome to C Field Academy yet again. This is Suraj and today we will discuss about another data structure which is queue. So it's pretty similar in terms of complexity with the previous data structure that we discussed, which is stack, or in fact even if we compare it with a linear array. So let's see what are the items which we will cover. So we'll first get started with the definition of a queue, what it is, where it is used, and things like that. Then we will go ahead straight away to the various operations that are possible on the queue. We'll see an overview of the operations, which means enqueue, dequeue, and the peek operation. Then we will go into each of these operations in detail with an example and pseudocode. We'll first start with the enqueue operation, then the dequeue operation, and then the peek operation finally. Once we are done with the operations, we will just see the time complexity of these operations, which means the enqueue, dequeue, and the peek. Then we will see different variants of queue that are used in applications or in computer science in general from undergraduate perspective. And finally, before we end, there will be an exercise for you guys which will be tried out, which you can actually try it out. So friends, let's get started with the queue. So what is a queue? Now, as the name indicates, and you guys might have heard it like a number of times, and in fact many times in a day, if you go to a shopping mall or any counter or any operations, always basically there is a queue. So which means the person who comes first is given a chance to be served first, and that's what we call the first in first out. So queue is a linear data structure. Linear data structure means data can be accessed linearly, wherein the collection of items or the items that are there can be accessed in first out manner. So the item that came first would be the item that goes out of the queue first. And this is how it happens. Normally items are removed from one end and inserted at the other end. So which means usually items are inserted at the rear end and removed from the front end, ensuring the item that came in first actually is removed first. Now queue can be implemented using an array or a linked list. In this video we will mostly concentrate on implementing using an array. And there are a variety of applications in the queue, even in not only in real life but even in computer science perspective. There are various scenarios. Let's say if you want to implement a buffer wherein we want to store data for a certain period of time and then remove the items in the same order that they came in. In job scheduling in operating systems, wherein the job that has come first will be served first or will be given CPU first. In graph traversals, especially in level order traversal or in breadth first search, we use a queue to store items and then remove the nodes from the queue. And finally, memory management is another area where queue is used extensively. Alright, cool. So I hope that kind of set the context a little bit what a queue is and where its applications are. Now let's go ahead and start seeing the various operations that are possible in a queue. So this is how a queue looks like. Normally there is a front, there is a back, items are inserted at the back. You can see 7 is getting inserted and 1 is getting removed from the queue. And the insert operation, or when the element is inserted, we call the operations as an enqueue operation, and when an element is removed from the queue, we call the operation as a dequeue operation. So what is an enqueue operation? So enqueue operation is the operation wherein a new element is added to the end of the collection, and definitely we check if there is available capacity. If there is no capacity in the queue, we cannot do it. Similarly, the dequeue operation. So dequeue operation removes the element from the head or from the front of the collection. And lastly, the optional operation, which is peek, which means we just go ahead and see the element that is at the head or the front end of the collection, but we don't remove it. We just see it and then we take some decisions based on it. So this is an optional operation which is generally not considered as a standard operation, but is used in variety of different applications. Okay, alright, now let's see each of these operations in detail with an example. So remember, as we already discussed, we will be implementing the queue using an array. So we are assuming that we have an array, and the array has a fixed initial capacity here, which is capacity, and a pointer. It's not a top pointer, it's the rear pointer. We will call it as a rear pointer, just to indicate where the size of the queue is. So capacity, the maximum size of the queue possible, normally decided during initialization, and then a rear pointer that points to the last element in the queue, and it also indicates the current size of the queue. And what we necessarily do is, when we are executing the operations enqueue and dequeue, we just need to move or insert the items and then adjust the rear pointer so as to indicate where the current element or the current last element in the queue is. So notice this is the queue which we have. Let's say we have 6 elements here: 4, 6, 11, 3, 5, 10. So normally capacity is the entire size of the queue, which is 8 in this case. Size is the current size, which is 6, and rear points to the 6th element in the queue, which is 10. Alright, cool. That's how we use normally to initialize or implement using an array. Now let's move ahead and see the operations that we discussed a short while back. So first is to add or enqueue an element to the queue. So first step to check, as we also did the same thing in stack, is to check if there is capacity. So which means we check if rear is pointing to the end of the array. So if rear is already at the end of the array and there is no element we can insert, we just return, or we don't do anything, or maybe just throw an error or print an error message. Otherwise, we increment the rear pointer and assign the element to this new position in the array. So something very similar to the stack. So let's say this is the queue which we have, which has size 8, and rear is pointing to the 6th element. The current last element is 10, and we need to insert a new item, let's say 7, or we need to enqueue the item 7. So what we just do is, we'll first move or increment the rear pointer to the next available space, and then we will move the item that we want to actually enqueue, copy it, and then we are done. Now because we had space, we didn't encounter any issues, and that's as simple as the queue operation. Let's see the queue or enqueue operations pseudocode. So here is the enqueue procedure, or the algorithm, and what enqueue does is it adds the item to the queue if there is capacity available. So queue is initialized with some capacity and has an initial rear value as 0. So which means when there are no items in the queue, the value of the rear pointer is 0. So here is the pseudocode. So first step to check is if rear +1, which means the next element to which rear is pointing to is within the capacity. If that is true, what we do is we increment the rear pointer and then we assign the new item to the queue, and then we are done. But if we have reached capacity, which means in that case we are unable to insert, we just throw or we print an overflow error. So this is what we did in the existing array or the queue which we had. So let's say in this case capacity is 8 and we have 8 elements in the queue. Sorry, we have 6 elements in the queue, 8 total spaces, and there is a rear pointer which points to the 6th element, that is 10. And let's say we need to enqueue an item 7. Now let's apply this procedure. So I'll write down 7 here because 7 is the item to be inserted. And the first step, what will happen is, in step 1 we'll check if rear +1 is less than capacity. Rear is 6 here, So 6 plus 1 is 7 and our total capacity is 8, so which is well under capacity, which means indicates we have space. So which means it will go to step 2, it will increment the rear pointer. Rear will now point to 8, sorry, rear will now point to 7, and we will assign Q rear, or the Q, the 7th location as the item, and then we are done. So it's as simple as that. Alright, now let's see the next operations, which is the dequeue and the peek, which are pretty similar with little difference. So to dequeue an element from the queue, what we do is, similarly we have to adjust the rear pointer. So first step to check is if there is element in the queue, otherwise there is no point in dequeuing, we will just return null. So first step is, if rear is pointing to 0, which means there are no elements present, we just return null, or we print an error message. Otherwise we return the element that is at the head position, not at the rear position, at the head, which means at the front of the position. But then since we remove the item from the head position, we need to make sure we move all items so that, you know, the new item, the next item is now at the head position. Now this is why, because we are using an array. If we were using a linked list, we didn't need to do this, but we need to move all the items one space to the front, so that the next item is now at the front of the queue. And then we go ahead and decrement the rear pointer by 1, so rear now again points to the last element in the queue. So this is how, let's say we have our existing queue, 4 6 11 3 5 10 7, 7 elements in the queue, rear is pointing to the 7th element, and let's say we need to remove an item, or we call the dequeue operation. When we call the dequeue operation, we need to remove the item 4 from the array. Now once we remove it, we need to adjust all elements, which means move all those elements one item to the left. So 6 now occupies the front position, 6 replaces 4th position, 11 replaces 6th position, and so on. And finally what we do is we also decrement the rear pointer, so that rear now points to the same item 7, but it's in the 6th position now. Cool. Now similarly the peek operations does the same thing as dequeue, but it doesn't remove the item. So which means we just go ahead, look for the item, and then return the item, or see the value. So here again we need to check if there are items in the queue. If the rear is pointing to 0, then we return null, otherwise we just return the element at the head position. So remember, we don't remove the element at the head position, and hence we don't need to move the items, or we don't even need to, you know, adjust the rear pointer. Cool. Let's see the pseudocode for each of these operations. So first of all, the dequeue operation. So dequeue operation removes an item from the head if there is capacity, if there are elements. So we are assuming queue is initialized with some capacity, and the initial value of the rear is 0. So which means when there are no elements, the rear is actually pointing to 0. So here is the pseudocode. It's a little lengthier than the Enqueue operation, but pretty simpler. So first step is to check if rear is greater than 0, which means there are elements in the queue. Otherwise we return an underflow error saying, you know, there are no items to be removed. If there are items to be removed, we go to step 2. We will first remove the item from queue, which means head of the queue, which is Q1. Then in the step 3 and 4, we move the items one item to the left, so which means we take a loop which starts from 1 to rear minus 1, and then we copy, which means we do qi equals to qi plus 1. We move all items one location to the left. Once we are done, we decrement the rear item, we decrement the rear variable, and then we are done. We just return the item. So that's as simple as that. Let's see this in action on the array which we took. We'll just apply the procedure here. So in this case, we have an array wherein the capacity is 8 over here, and then we need to let's say call the dequeue operation. So the first step is to check if rear is greater than 0. It is definitely, because rear is 7 here. And then we go to step 2, where an item equals to q1. So item 4 is removed from the head of the queue, we can see. So that is step 2. Once that is done, the next operation, which is step 3 and 4, we copy the items one by one to the left, which means we start from I equals to 1 to rear minus 1. So we will start with I equals to 4 and we'll copy q plus 1, which means we'll copy 6 and replace 4. Then we will copy 11 and replace 6. We'll replace 3. We'll copy 3 and replace 11. Similarly, 3 will be replaced by 5. 5 will be replaced by 10, and 10 will be replaced by 7. And that's how we get the next queue, the values in the queue. Notice then the next step, in step 5, we adjust the rear position. We decrement rear equals to rear minus 1, and so this is the current state of the queue. Notice the head element has now changed. It's now 6. Earlier it was 4, but 4 has been removed now. Awesome. So that was the dequeue operation. Lastly, the peek operation, which is the optional operation. So very similar to the dequeue operation, we remove an item, we don't remove an item from the queue, but we just look at the item and return its value, which means we'll get an item from the queue but not remove it. So the pseudocode is pretty similar, but we don't need to now adjust the rear pointer, and we don't need to move the elements to the left. So that's why what we check is, we just check if rear is greater than 0, which means there are elements in the queue. We assign, remove, or we assign the element that is in q1, and then we just return the item. There is no need for any more further adjustments. Now this is how it will look like with an example. Let's say we have our original array queue, which had 7 elements in it. The capacity is 8, and initially rear points to 7, or the 7th element. So the get or the peek operation, what it will do is it will just go and check and get the value of 4. And once it gets the value of 4, we are done. That's it. There's no need to move any elements, and that's what the peek operation is. Alright, cool. So looks like we are done with all the 3 operations. Pretty simple and small operations. The next, let's go ahead and see the time complexity of each of these operations. So we'll just discuss the dequeue operation in detail, because if you remember, in queue we are actually doing nothing much. We are just adding one item, but it's the dequeue which is a little complicated. So let's first analyze the dequeue method. So the dequeue pseudocode looks more like this. There is only one for loop, which more or less runs from 1 to n, or n means basically the size of the rear, current size of the queue. Assuming it to be n, the outer loop will run n times. So this is where the about n operations are executed in the dequeue method. Other than that, there is nothing much done. So the total operations is about n. In fact, it's n minus 1, or it's rear minus 1, but we'll approximate it to n. So that's why the complexity of dequeue operation is order n, because in worst case we have n items, which means the the queue is full and we are removing one element, then we need to do n minus 1 swap or copy operations. Alright, let's see the other operations as well. So we'll see, we already saw the dequeue operation, which is order n, because what we do is we remove an element and then all items are moved over one position to the left. Then let's see the enqueue operation. In enqueue operations, what we do is we just add an element to the end and increment the rear pointer 1. So we are not doing much of work in terms of the size of the queue. So we are just doing one operation, that's why it's order 1. Then the peek operation, which also does nothing, we just go ahead and check the head element. We don't move any elements or do anything, so that's also order 1. So as you can see, this is how the time complexity of various operations is. It's only the dequeue operation which actually is costly here, which runs in linear time to the size of the queue. Cool. So that was the time complexity, and finally let's see another we'll see another few variants of the queue which are being used in especially in computer science. We won't go into detail, but just go through an overview of each of these queue types. If you want to go into the detail of it, I would recommend seeing an undergraduate textbook, or maybe some articles or references on web which can give you more idea about it. So the first one is a double-ended queue. Let's forget about this column for now. It's a mistake, I added it here, so let's forget about it. It has nothing to do. So we have a double-ended queue, so it's similar to a normal queue, but what additional thing it does is it allows enqueuing and dequeuing at both queues. So sometimes this is also called as Dequeue, that's how it's pronounced, which means items can be added and removed at both the ends. And normally this is something which will be implemented efficiently using a linked list. In fact, using array also it can be done. The next is priority queue, in which what happens is it's a normal queue, but there is an additional value attached to each item, which is the priority. And when the items are removed, we remove the highest priority item from the queue, regardless of whether it's at the head or not. So we just check the highest priority item and remove it, and then make adjustments. The last is the circular queue, which is a very interesting concept, wherein the first and last locations are connected, which means the queue size is fixed, and the pointer or the rear pointer can move in a circular way, something like this. So you can see the rear item, if it starts at 0, it will increment till 7, and when it's further incremented after 7, it will go ahead and reach the first location, which is 0. So this is a circular queue example. So I think with this we are pretty done with this video. I hope this video helped to understand what a queue is and how different operations are used in a queue. Finally, before we end, here is a very short exercise for you guys to try it out. Imagine there is an empty queue you have, and you want to insert a few items, which is 5, 10, 12 and 8, that are inserted to the queue. And then look at the queue, how it looks like, what is the current head, what is the current rear, and things like that. Then go ahead and remove 2 elements out of this queue. Lastly, a question related to real life. Just imagine, look around and see what are the different applications that you see in real life, be it a ticketing counter, or maybe a driving license office, or any other operations that you see. Maybe you are purchasing some item in the supermarket, things like that. See, and then see how it's actually used. So think of some real life examples, and also think of some examples in your, from the context of computer science, from your memory, what you have come across, like in operating systems, or in any other problems, or maybe in programming scenarios where you see that the queue is used. Alright, so we have reached the end of the video. Thanks guys for watching it. I hope it gave a perspective or an understanding of what a queue is. Bye bye, and see you again in the next video.